Hello and welcome to another video from sickmaths.co.uk, sickmafs.co.uk, where you can find lots of Key Stage 3, GCSEI, GCSE and A-Level maths videos. This one's about factor and remainder theorems, which is part of the C2 A-Level maths module under Edexcel. So let's begin with a bit of theory explaining what it is and how it works. If you've got a function and it's equal to x minus a times something plus the remainder. Okay, you might be thinking, wow, where did I pick up all these things? Where did the x minus a come from? Actually, x minus k could be any number, right? A function can be made up of anything, two things timed together plus a bit more, right? That's fair enough. Very easy to do. So this function, x minus a, is nothing really special. Okay, but I want to demonstrate something, which is this thing. If you made x equal to a, if you were assuming there was a function x minus a inside it, then that x would become an a, and you get a minus a, which is nothing. Nothing times something is still nothing, i.e. 0, and what will be left over is that plus remainder bit, which is the remainder. Okay, so f of a would equal the remainder in this case. Now I have to explain, why do I call it the remainder? It's fair enough calling an extra thing, isn't it? Yeah, but why remainder especially? Because another way of looking at this is that if you do f of x divided by x minus a, the answer would be this plus the remainder. So that's the reason why I'm calling it a remainder. Now anyway, turning back to this, f of a equals the remainder. That's a really important result. Okay, but if f of a equals 0, that means you're saying there is no remainder, because f of a should equal remainder, but if f of a equals 0, you're saying the remainder is 0, and that means there's no remainder. That means, if you look back at the original function, that means x minus a is a factor of the function, because there's no remainder. That means f of x equals x minus a times something. That's another way of saying this is a function of the entire, this is a factor of the entire function. So just look at it carefully a little bit here. You don't have to memorize it inside out, but it's good to understand what's going on because it helps you remember in the future. So what is factor theorem? Factor theorem says if you put a number in, okay, into the function and the answer is 0, that means you've effectively found the factor. Okay, I'm going to show you how that works exactly, but you can see it's sort of the opposite of the number you put in. Now if you don't get 0 and you get a number of any sort, okay, that is called your remainder based on this theory you just explained here. Okay, so whatever number you put in, that helps you find your remainder, and that effectively also tells you what you divided by, i.e. the opposite thing. Okay, so the remainder theorem is when you get the remainder. When you get the 0, that's factor theorem. It's basically the same thing, just two sides of the same coin. Now, here, that's the theory done. Let's do a bit of practice, and it's really easy. Okay, if you've got a function fx equals blah blah blah, and you substitute if you substitute x equals half and you get 0, so this is where factor theorem comes in, that tells you that 2x minus 1 is a factor of fx. How did I get 2x minus 1 from half? I get x equals half rearranges to 2x minus 1 equals 0, and that tells you what your factor is. You just have to rearrange it to make it equal to 0. Now if I put 1 into the function, so x equals 1, and the result is minus 6, that means minus 6 is my remainder if I do f of x divided by x minus 1. How did I get x minus 1 from 1? Again, I do x equals 1, gives me x minus 1 equals 0. Just rearrange it to make it equal to 0, and you know what you divided by. So factor theorem and remainder theorem are really easy. Look out for 0 for factor theorem, and just rearrange x equals blah 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 equal to 0, and then you know what the factor is, and the answer over here immediately tells you what your remainder is, and if you want to know what you divided by, then you just make x equals blah blah into equal to 0, and you got the thing that you divided by. Now, you might be wondering, how did he even come up with these numbers? Well, you have to do a bit of guessing. Usually it's not something awkward like half, to be fair. Okay, they don't like to be so mean. You just have to guess a few numbers from 10 to minus 10. But that's quite time consuming, isn't it? Yeah, especially when you have to put each of those numbers into this function every single time. Hopefully you understand how to put a number into the function. For example, if I did f of 1, that means x equals 1, that means x equals 1 here, there and there. So you 2 times 1 cubed minus 3 times 1 squared minus 11 times 1 plus 6. If you work that out, that's 2 minus 3 minus 11 plus 6, which is minus 6. I hope. Yes, it is. Okay, now, using the calculator to do that stuff for you, okay, to guess for you, guess all these different values, okay, is really simple. You press the mode button. Oh, by the way, I'm assuming you're using my favorite calculator, which is the Casio calculator, which most people use, and the reason I think it's great is because it's just got a great display that you can work with. It's just you can write fractions really nicely and stuff like that. Anyway, so, which Casio calculator I'm talking about? You know, the one that's really popular with the massive blue button or whatever right in the middle that helps you navigate up, down and whatever within the maths that you've written. Now, you press the mode button to do this thing we're about to do. Press the mode button, as you can see there, it's near the top. It's at the top actually, and you get a couple of choices. Press 7 to choose the table function, and what it does is basically you write a function of your choice, like this sort of thing, like we've done just x squared. Okay, and how do you write a function of your choice? Well, you have to write x at least. It starts off with fx for you, and then you write alpha to just get hold of the X on top of one of the buttons. There's a Y as well, and I think there might be a Z. Okay, so you can write different letters, but really you don't want to bother with that. So you put alpha, this button here, which gives you the X, because the X is in purple and alpha is in purple. Maybe I should have it in colour? No, I can't bothered. And then I just press some random function to demonstrate that you can do something to the X. I could have done 3x if I wanted to, but I thought let's do x squared. Okay. And then I press equals. That just gets me to the next screen where it asks me the next question. Where do I want to start guessing from? Where do I want to start? What's the lowest number I want to put into this function? Yeah, I want to start from one point. Like over here I said start from minus 10 and go to 10, positive 10. So I could type minus 10 if I wanted to. Where do I finish? Let's say positive 10. Okay, and keep pressing equals to get to each next screen. So I do minus 10 equals 10 equals, and then let's guess every half unit. So what's the difference between each of my guesses? Let's make it 0.5. Yeah, so, and then I press equals, and it gives me the result. So shows me all the guesses for x. Okay, so 1, 1.5, 2. I blatantly didn't put in 10 and minus 10, did I? Anyway, so this one started with x equals 1. And these are the results. I put it in, and I'm not sure what the function was, but it wasn't x squared, it was something else. Anyway, and then there's a lot more results. This is the first 3 results, and I keep scrolling down to get more results. Now, finally, here's a very common kind of question that you get asked. Basically, you get a function fx equals ax cubed minus 3x squared plus bx plus 6. Basically, a's 2 letters that you don't know usually are stuck into the function, and you're told 2 things to work out each of those letters, because this is obviously going to turn into a simultaneous, because you need 2 equations to help you work out the 2 letters or 2 unknowns. So you're going to get 2 equations by these 2 facts. So you're told that f of 3 is equal to 0. Another way of writing that is x minus 3 is a factor, and then that will tell you that you should substitute 3 into the function, and you can get 0. And then you're told f of 1 equals minus 6, or the remainder is 6. is another way of saying it. They say it all sorts of ways. You have to interpret it from what I've already explained to you. So f of 1 equals minus 6. Another way of saying that if fx was divided by x minus 1, the remainder is minus 6. Things like that, yeah? So you use those two facts by basically f of 3 means you have to put 3 into the function. So I get 27a because that's 3 cubed is 27 times a, etc. You put it in the numbers and you get this equation. You put in the numbers for that, you get this equation. Remember, f of 3 was equal to 0, so I have to equal 0 there. F of 1 equals minus 6, so I put 1 into the function and the result has to be minus 6. Put them together simultaneously, times or whatever you need to do, to solve linear simultaneous equation. That's a GCSE thing there. And the answers are a equals 2, b equals minus 11. If you don't know how to do that, just check out my GCSE video on simultaneous equations and linear equations. So thank you for listening. Hope that was useful.